Students, welcome to my YouTube channel. In this video lecture, we are going to look at some great circle questions from Keith Williams' General Navigation book. Now, the concept of great circle, drum lines, convergency are very important for your CPL, ATPL, and airline exams. I have already solved convergency-based, great circle-based, drum line-based questions from RK.Bali and Oxford General Navigation book. So do check those videos if you haven't yet. In this particular video lectures, I'm going to solve all the 120 questions, but in a series of 20 lectures, meaning I will be solving 12 lectures. I will be solving 10 questions in every video lecture. So let's start with question number 1 now. A great circle track joins position A 59 degrees south, 141 west, and B 61 south, 148 west. What is the difference between great circle track at A and great circle track at B? So let's plot this. Both positions are in the south hemisphere, and so let's say this is your horizontal representation of the Earth's surface. Okay, this is your prime meridian 0 degree. This is your equator 0 degree. Okay, so first position is 59 south, 141 west. 59 south, 59 south is here, 141 west. Second, Bravo 61 south, 148 west. 61 south, so over here 61 south, 148 west. Okay, so the direction of your flight will be southwesterly. Southwesterly, Alpha to Bravo, southwesterly direction. Fine. So let's draw this again. A is here, B is here. Since you are in the southern hemisphere, the great circle will pass to the nearest south pole. So this is your great circle, this is your rum line. Okay. What is the difference between great circle track at A and great circle track at B? Now, remember there are two definitions of convergency. First, convergency is nothing but the angle of inclination, the angle of inclination between two meridians. And second definition is convergency is the difference between, is the angular difference between two great circle tracks. Two great circle tracks. Okay, so let's find out convergency here. Convergency equals to d long in terms of degree into sine of latitude. So what is the difference in longitude here? 141 west, 148 west. So the difference between them is 7 degrees into sine of latitude. Now here one latitude is 59 south, another latitude is 61 south. So the average of that is 60. So sine of 60. Next, convergency will be sine 60 into 7, that is 6 degrees. 6 degree 3 minutes. Okay, so 6 degree. So that is your convergency. So your final answer is, what is the difference between the great circle track at A and great circle track at B? So the difference will be equal to 6 degree. Now whether this difference will be more than 6 degree or less than 6 degree, meaning the great circle track at A, whether the great circle track at A will be more than great circle track at B by more than 6 degree, or will the great circle track at B will be more than the great circle track at A by 6 degree. So you will have to draw DIID diagram. Okay, DIID diagram. So that is nothing but this is your north hemisphere, this is your south hemisphere, this is your easterly direction, this is your west. Now if you are in the north hemisphere and you are traveling in the easterly direction, you are in the north hemisphere, anywhere in the north hemisphere, you are traveling in the direction of east. So in that case, the great circle direction will increase. If you are in the north hemisphere and you are traveling in the direction of west, in that case the great circle direction will decrease. Now come down to south hemisphere. If you are in the south hemisphere and you travel in the direction of west, so what will happen? The great circle direction will increase, and if you travel in the direction of east, being in the south hemisphere, the great circle direction will decrease. Okay, so this is DIID. Now in this particular question, we are in the southwest hemisphere. We are in the south hemisphere, flying in the direction of southwest, meaning we are flying westerly direction, and southern hemisphere. So if you are in the westerly correction, if you are in the south hemisphere and you are traveling westerly, so the great circle direction will increase. That means going from point A to point B, the great circle track at A, or let's say great circle track at B, the final great circle track at B will be more than great circle track at A, the initial great circle track at A, by a value of 6 degrees. By a value of 6 degrees. Position alpha 45 north and some longitude. Position Bravo 45 north and 45 degree 15 minutes east longitude. Meaning both positions are located on same latitude. Distance between them 280 miles. Bravo is to the east of A. What is the longitude of position A? So let's say this is your representation of the earth. This is your prime meridian, 0 degree. Now Bravo is to the east of A. That means Bravo is somewhere here, let's say. A will be somewhere here, or A can be totally in the western hemisphere also. Okay, we will find that out. Where exactly? So Bravo is to the east of A, so Bravo is to the right of A, or from this right of this particular A, alpha. Now both are at same latitude. So 45 degree north. 45 degree north. Okay. Longitude of Bravo is 45 degree 15 minutes east. Okay. We have to find the longitude of A. Now distance between them is 280. So it can be 280 like this, or it can be 280 if like this also, if alpha is in the western hemisphere. So we know that if two latitudes or if two positions are on the same latitude, the line joining them will be the rhumb line distance or the rhumb line. We all know that all parallels of latitudes are rhumb lines. The equator is one parallel of latitude which is both a rhumb line and a great circle. But now we are at 45 north latitude, not the equator. So the distance between them, which is 280 nautical miles, is nothing but a rhumb line distance. So rhumb line distance equals to d long in terms of minutes into cos of latitude. So 280 d long in terms of minutes cos 42. Correction, cos 45. So d long in terms of minutes will be equal to 280 divided by cos 45 is 395.9 or 396 minutes. Now 396 minutes divided by 60 is equal to 6 degree 35 minutes. Okay, in terms of degrees, 6 degree 35 minutes. That means if Bravo is 45 degree 15 minutes east, alpha will be, the longitude of alpha will be 6 degree 35 minutes east, different from this value 45 degree 15 minutes. So if alpha is to the east of Bravo, correction, if alpha is to the west of Bravo, so we will have to subtract that d long value from this value, because going westerly, the longitudinal values will decrease 45, 40, 35, 30, so on and so forth up to prime meridian. So longitude of A will be equal to longitude of B minus d long. Longitude of B is 45 degree 15 minutes east. D long is 6 degree 35 minutes. So 45 degree 15 minutes minus 6 degree 35 minutes. So that is equal to 38 degree 40 minutes east. Okay, so we are still in the eastern hemisphere because the difference between alpha and Bravo is very small, 6 degree 35 minutes. This will limit the position of A in the eastern hemisphere itself. If the difference had been more than 6 degree 35 minutes, if the difference had been equal to 45 degree 15 minutes, which is the difference between prime meridian 0 degree and longitude of B, then our position A would have been in the western hemisphere. So this is how you come to know whether position A is in the east hemisphere or west hemisphere, looking at the D long, the difference separating them. So longitude of A will be 38 degree 40 minutes east. A Lambert's conformal chart has a constant of the cone 0.75. The initial course of a straight line drawn on this chart from alpha to Bravo is 0.43 at alpha. At Bravo, that direction is 0.055. What is the longitude of B? Now on a Lambert's conformal chart, a straight line is equal to your great circle track. Great circle track. So in this case, they are telling you that flying from A to B, great circle track at A is 0.43. Flying from B to A, great circle track is 0.55. Okay. So constant of the cone is given to you 0.75. Now constant of the cone is nothing but sine latitude. Constant of the cone is another term for sine latitude. So use convergency formula. Convergency is d long in terms of degree into sine latitude. We can also write this formula, which is d long in terms of degree into constant of cone. So in place of sine latitude, I have written constant of cone. Now we know that the difference between two great circle tracks is equal to your convergency. Now what is the difference between 55 and 43? It is equal to 12 degree, right? D long, and what is the constant of cone given? Sine latitude is 0.75. So D long in terms of degree will be 12 divided by 0.75. So 12 divided by 0.75 is 16. So that means the difference between these two longitudes is 16 degrees. Okay, 16 degrees. Now A is at 40 north, 50 west. Traveling A to B, we are flying a direction of 043, a northeasterly direction. So let's draw that. A to B, A is here, B is here. Since you are in the north hemisphere, the great circle will be uh, okay towards the northern pole. Since this is Lambert chart, we need not draw that. A to B is a great circle track. So looking at the direction, we come to know that A is to the east of Bravo. So A is 50 west. A is 50 west. A is 50 west. What will be the direction of or position of Bravo? Longitude of Bravo will be 16 degree different from longitude of Alpha. Now going in the easterly direction. So you are you are in the west hemisphere. Okay, so this is your west hemisphere, the west of prime meridian. So when you are traveling from a particular position in the western hemisphere in the easterly direction or northeasterly direction, what will happen to the values of your longitudes? The longitudinal values will decrease because you are traveling easterly towards this prime meridian 0 degree. So longitude values will decrease from 45, 40, 35, 30, so on and so forth. So, so 30, 50 west will become 50 minus difference 60, 50 minus 16, that is 34. So your position B longitude is 34 degree west. 34 degree west. The difference between them being 16 degree. Okay. Next. What is the great circle track from 70 degrees south 30 west, 70 degrees south 60 east? So both are in the southern hemisphere and same latitude. So 30 west, 60 east, same latitude, 70 degrees south, alpha to Bravo. Since you are in the south hemisphere, the great circle track will be towards the south pole. Now, we have been told to we have been asked to find great circle track from A to B. Now let's write this. Drumline track from A to B will be what? Drumline track A to B. It will be equal to 0 degree. Correct? Both are located on same latitude, and all latitudes are your drumline tracks of constant direction. East या फिर west. Now here you are traveling from 30 west to 60 east. Means you are traveling in the easterly direction. That's why line AB is 0 And now if you want to go in reverse, go reverse. B from B to A, you will be traveling a line direction of 270. 270. Okay. Now great circle track at A to B will be equal to this line track 0 plus this additional conversion angle plus this conversion angle. So great circle A to B will be line plus this conversion angle. Correct? So that will be equal to line plus conversion angle. So 0 plus conversion angle. What is convergency here? Convergency is nothing but B long in terms of degree into sine of latitude. So what is the difference between the longitudes here? 30 west and 60 east. So 60 and 30 is 90. Latitude is 70 south. So sine 70 into 90 is 84 degree 34 minutes. Conversion angle will be half of that. That is 42 degrees 17 minutes, or approximately 42 degrees. So substitute the values. 90 plus 42 is 132. So great circle track from A to B will be 132 degrees. Easy. Next. What is the longitude of a position which is 6 miles to the east of 58 degree 42 minutes north, 94 degree west? So this is your earth. This is your prime meridian 0 degree. Okay. Position A is 5842 north, 094 west. And another position is to the east of this position A. That means it can be the next position can be east of A, means in the western hemisphere itself, or it can be totally in a complete different hemisphere in the eastern hemisphere. So there are two possibilities. Now, which one of these possibilities applies to us can be found out by finding out D long. So now both are at same latitude. How? How do you come to know that? Since both are, or since it's mentioned here, position Bravo is to the east of A. So that means it's directly to the east of A, meaning or signifying both are located at same latitude. Okay, so now all latitudes are Rammline tracks. So here the Rammline distance formula should be used, which is d long in terms of minutes into cos of latitude. So Rammline distance is 6 miles, d long in terms of minutes into cos of 58 degree 42 minutes. So d long in terms of minutes will be 6 divided by cos of 58 degree 42 minutes, 0.5 is 12 minutes. Divided by 60 is again 12 minutes, so 0 degree 12 minutes. Okay, so the difference between them is very small. That means Bravo will be in the western hemisphere itself. What will be the longitude of Bravo? Longitude of Bravo is longitude of alpha minus d long. Why subtraction? Because going easterly direction in the western hemisphere, the values of longitudes will decrease. So 94 west minus 0 degree 12 minutes. So 93 degree 48 minutes west is the position of Bravo. Okay. Question number 6. In an inertial navigation system, you have put erroneous positions. Okay, you have put wrong positions. So the coordinates of the departure aerodrome 35 degree 32 minutes, 35 degree 32.7 minutes north, 139 degree 46.3 degree west. You have put this. So this is the wrong coordinates that you have put. The correct coordinates are 35 degree 27 minutes, 35 degree 32.7 minutes north, 139 degree 46.3 minutes east. Okay, these are the correct coordinates. So instead of that, you have put this coordinates in the system. Now, when this aircraft takes off, okay, and begins its journey, it passes a position called 52 degree north, 180 degree west. Now, when it passes that position, what will be the longitudinal value shown to you in the system? Now, if you had put the correct position, the correct longitudinal position at the time of departure, the system would have shown the correct longitudinal position of this particular checkpoint. But since you have put a wrong position at the beginning, what will happen? All the subsequent positions will also be reported wrongly, right? So they have asked us to find the wrong position that will be shown to us when we pass this position or when we pass this particular checkpoint or waypoint. So, so now what is the difference of error between them? The magnitude of error or the difference of error between the position that you have put and the actual position is equal to one. Okay, latitude is correct, longitudes are put wrongly. 139 degree 46, 139 degree 46.3 minutes west. Since both are in the different hemispheres, we are going to add the difference between them. And same 139 degree, 46.3 minutes east. So when you add that, the difference will be equal to 139 degree, 46.3 minutes plus 139 degree, 46.3 minutes. So that is equal to 279 degree, 279 degree, 32.6, 279 degree, 32.6 minutes west. Okay, because the actual position or the accurate position of this aerodrome is in the eastern hemisphere, and the error that you have put, the wrong input that you have given, is in the western hemisphere. So the magnitude of error is in terms of, or is in the direction of west. Okay, next. Now, second step number 2, the position that they have given is 52 degree north, 52 degree north, 180 degree west. This is the position that you are going to overfly. Now, when you overfly this position, the longitude shown to you will be erroneous, will be wrong, and will be different from this original or accurate longitude by a value of 279 degree 32.6 minutes west. That means the longitude that will be shown to you will be 279 degree 32.6 minutes west of this accurate longitude. So longitude shown to you will be equal to 180 degree west plus this error. So at 279 degree, 32.6 minutes west. Okay, since it's to the west of it, you are going to add. So 180 degree plus 279 degree, 32.6 minutes. That is equal to 459 degree, 32.6 minutes. Okay, now we have maximum 360-degree longitudes, right? 180 in the west hemisphere, 180 in the east hemisphere. So what you are going to do is you are going to subtract 180 from this value, 180 degrees. So subtract 360 degree, 459 degree, 32.6 minutes minus 360 degree, that is 99 degree, 32 minutes, point 6, 32.6 minutes west. So you have made a 459 degree, so 360-degree full rotation and another small rotation in the western hemisphere. So let's say this is your globe. This is the North Pole, prime meridian, 180 west, 180 east, 90 west, 90 east. So the whole difference, the big difference is 459 degree. So 459 degrees more than 360 degree, this complete 360 degree, and additional 459 degree minus 360 degrees equal to 99 degree 32.6 minutes. Okay, so another 90 after completing a 360 degree turn rotation, you will again travel another 99 degree 32.6 minutes in the western hemisphere. This side is the western hemisphere. So somewhere here. So your position will be here, 99 degree west. So when you pass this particular position, okay, the longitude shown to you will be 99 degree west. Instead of showing a longitude of 180 west, you will be wrongly or erroneously or falsely shown a longitude of 99 degree 32.6 minutes west. Aircraft flies the following drumline tracks from 4 degree north 30 minutes west. Okay, so this is your prime meridian, this is your equator. your initial position is here, let's say 4 degree north, 30 degree west. You travel 600 nautical miles south direction. So when you travel from south, southerly direction, from 4 degree north, be you can end up being in the northern hemisphere itself, 1 degree north, 2 degree north, whatever, or you can cross the equator and end up being in the south hemisphere. So we will come to know that when we calculate the difference in latitude, okay, between the initial position and final destination. Okay, and then we will check whether the destination is in the north hemisphere or south hemisphere. So we are traveling a distance of 600 nautical miles south. That will be your great circle distance. When you travel along a meridian of longitude, you travel a great circle track. So hence a great circle distance d lat into 60. 6 10 degree. So now the difference between equator and 4 degree north is 4 degree. And here the difference that we have got is 10 degree, which is more than 4 degree by additional 6 degrees. So that means your destination will be in the south hemisphere. So the difference is 10 degree. So 4 degree this equator and 4 degree north, and additional 6 degree in the south hemisphere. So your final destination will be 6 degree north, same longitude 30 west. From this position, you are traveling 600 nautical miles east. 600 nautical miles east. Okay, so you can be in the western hemisphere or you can cross the prime meridian and end up being in the east hemisphere. Let's find that out, whether we are going to stay in the same hemisphere or enter a new hemisphere. So that will be a rumline distance when you follow a rumline track east or west. Be long in terms of minutes into cos lat. 600 divided by cos lat, cos of 6 degree. This will be 6 degrees south. Okay. D long in minutes. So D long in minutes will be 600 divided by cos 6, that is 603 minutes, also known as or 10 degree 10 degree 3 minutes easterly. So your initial longitude is 30 west. The destination longitude will be 30 degree west minus this D long 10 degree 3 minutes. Okay, because going easterly in the western hemisphere, the longitudinal values will decrease. So we will draw it here, over here. So 6 degrees south, and longitude, new longitude will be old longitude minus B long, 30 west minus 10 degree 3 minutes. 19 degree 57 minutes west. So you are still in the western hemisphere. From this position, aircraft travels 600 miles north When you travel 600 miles north, again you will end up at same latitude, 4 degree north. Okay, so same like this. So I'm going to write here 4 degree north. Longitude will be 19 degree 57 minutes west. Now from this position you travel another 600 nautical miles easterly. You travel another 600 nautical miles easterly. So the Ramline distance will be d log in terms of minutes into cos lat. So 600 divided by cos 4, that is your d log in minutes. So that is 601 minutes divided by 60, 10 degree 1 minute. So approximately 10 degree is your d log. Now your initial longitude is 19 degree 57 minutes west. You are traveling westwards. So traveling westwards, new longitude will be initial longitude or old longitude plus d long. Why d long? Because you are traveling west in the west hemisphere. Okay, so the values will increase. 19 degree 57 minutes west plus 10 degree d long, that is 29 degree 57 minutes west. So it is very close to 30 degree west, but it is 3 minutes before that. 3 minutes before that. So your final position is somewhere here. Somewhere here. So you are going to select that value which is closest to this longitudinal value. Next. Which of the following differences in latitude will produce the greatest difference between initial great circle track and mean great circle track? Between 2 points which are separated by 10 degree change in longitude. Now mean great circle track is another term for your Ramline track. Let's say these are the two positions A and B. This is your great circle, this is your Ramline. Now we know that Ramline track will have a constant direction east or west. But the direction of this great circle will change by the value of convergency as it travels from A to B. Okay, so along the journey, the direction of this flight will keep on changing until it goes until it arrives at position Bravo. And that change will be equal to convergency. Now, mean great circle is nothing but average great circle. So this is the starting point, this is the ending point. The average or the mean of that is nothing but a point somewhere here. Point somewhere here. And the direction of this point here will be parallel to the direction of this rum line. That's why we say average great circle is nothing but rum line direction. So indirectly they are asking us to find the latitude where the difference between your great circle track and your rum line track will be maximum. Now the difference between great circle track and rum line track is called convergency angle. Convergency angle is nothing but half of convergency. So what is convergency? Half is a constant value, so ignore that. Convergency is d long in degrees multiplied by sine of latitude. That means your the difference between great circle and rum line will be directly proportional to your sine of latitude. Now the first option here is 30 degrees south, 25 degrees south. So what is the difference between them, 30 degrees south and 25 degrees south? So the average of these two latitudes is 30 plus 25 divided by 2, 27.5. And d long is 10 degree. So case number 1, convergency equals to d long into sine of latitude, sine of 27.5. So sine 27.5 into 10 is 4.6, 4 degree 37 minutes. Option Bravo, 30 south and 30 north. So one is in the south hemisphere, another is in the north hemisphere. So we eliminate this. Charlie, 60 north and 55 north, right? So convergency will be D long, which is 10 degrees, into sine of latitude. So the mean of 60 and 55 is 57.5. So sine of 57.5 into 10 is 8 degree 26 minutes. And delta again, both are in different hemispheres. So eliminate. Now, this is 4 degree 37, this is 8 degree 26. So the higher value is 8 degree 26 minutes. So the correct answer will be option Charlie. So which of the following differences in latitude will produce the greatest difference? So the difference between 60 north and 55 north will produce the greatest difference between the initial great circle track and mean great circle track separated by 10-degree longitude. Next, what is the final position after following drumline tracks and distances? 60 north, 30 west. From there, you're traveling south for 3,600 miles, then east, then north, then west, similar to the previous question. The starting point is 60 north, 30 west. So let's draw the diagram. This is your prime meridian. This is your equator. Initial position is 60 north, 30 west. From here, you travel south for 3,600 nautical miles. So what will be your destination? Great circle track. Great circle distance is d lat into 60. So 3,600 miles divided by 60 is equal to d lat. So that is equal to 660 degrees. Okay. So your final destination will be 60 north minus d lat since you are traveling south. So d lat is 60. That means you are arriving at the equator. Your destination is at the equator somewhere here. Okay. So 0 degree north south, longitude remains same 30 west. Now from here you travel another 3,600 miles easterly. So you are traveling easterly direction. So step 2, drumline distance d long in minutes into cos lat. So 3,600 divided by cos equator d long in minutes. Cos 0 is 1, so this is 3,600 minutes divided by 60, that is 60, yeah, 60 degrees easterly. So your new longitude will be 60 degree east of 30 degree west. So now the difference between 30 west and 0 degree is this d long is equal to 30 degree. The total difference, total d long that we have got is equal to 60 degree. So we have covered 30 degree. Another 30 degree will be covered in the eastern hemisphere. Another 30 degree will be covered in the eastern hemisphere. So your destination will be equator and the longitude will be 30 degree east. 30 degree east. Now from here you travel north for 3,600 miles. You travel north for 3,600 nautical miles. So your final destination will be same longitude and latitude will be the same 60 degree north, 30 east. From here you travel west for 3,600 nautical miles. So line distance d long in minutes into cos lat. that is equal to 7200 minutes, which is equal to 120 degree, right? 120 degree. So now the d long between prime meridian and 30° east is 30° d long. Our total d long is 120. So 120 minus 30 is 90. So another 90° d long will be in the western hemisphere. In the western hemisphere. So your final destination will be prime meridian से लेके somewhere here, extreme end. The longitude will be 90° west longitude. So new longitude will be, new coordinates will be 60° north, 90° west longitude. So prime meridian, which is 0 से लेके d long, remaining d long is 90°. So 90 west. So our final destination will be to the west of our initial departure point. Okay. Next, last. Great circle bearing of B from A. So B from A matlab you are going from A to B. So I can say I am traveling from A to B, or I can say I am arriving at B from A. So either way, the meaning is the same. Either way, the meaning means the same. So we have to travel from A to B. So A is 30 west. Both are at same latitude. A, B, and great circle is this. Drumline track A to B will be 090. Since both are located on same latitude and latitudes are rum lines traveling in fixed direction east-west, great circle A to B will be rum line A to B plus convergency angle. So 090 plus convergency angle. What is convergency between them? D long in terms of degrees into sine of latitude. So D long between them is 30 west and 60 east. So that is 90°. Sine of latitude, sine 70. Sine 70 into 90 is 84.5. So convergency is 84.5° or 84°, 34 minutes. Convergency angle will be half of that, 42°, 17 minutes. So 090 plus 42°, 17 minutes is equal to 132°, 17 minutes. So great circle direction is 132° approximately. So this is how you do all the questions. I hope you have understood all the 10 questions that I have answered in this video lecture. This great circle drumline convergency questions are uh, a bit long, and they take much time, okay, to solve them, to understand them, since they involve drawings, figures, writing down formulas, substituting the values using CX3, and you have to pay very careful attention that the values you put in your CX3 on your sheet of paper are the correct ones. If you copy the wrong values, the whole solution will go wrong. Correct. So these questions take a little bit of extra time compared to other similar questions from Gen Math. So the solution or the key is to practice as many questions as possible of this great circle questions from all the resources available, and to set a timer. The more questions you solve, the more confident you become, the more familiar you become with your strengths and weaknesses, and when you know them, you will be able to manage your time effectively. So best of luck. In my next video lecture, I will come up with the next 10 questions. So let's meet then.